Good evening, explorers. I'm Explorer Torie, and welcome to another episode of Native Nevada Nature by the Conservation League. This is my weekly series to highlight one native plant or animal species that's here. So if this is your first time joining us, welcome. This is an educational presentation that is for all ages to watch, enjoy, and learn. You can check us out every Wednesday at 5 p.m. You'll learn a new fact about what animal or plant we're talking about, and there'll always be questions if you want to know more as well. So today we're going to be talking about the Ichthyosaur, which is Nevada state fossil. Throughout the presentation, if you have any questions or comments, please put them in the comments section, and I will go through questions at the end of this presentation. Now, in order to accurately look at the Ichthyosaur, I think we need to do a little bit of traveling. That's right, explorers. Go ahead and strap yourselves in and get ready because I think we need to go back in time. So everybody, let's get into the time machine and go back, way, way back. So it's going to be a bumpy ride, so hold on, and here we go. Say goodbye. Bye, desert. All right. Whoa. Oh, no. Oh, no. We're traveling. We're time traveling. Wait a second. The desert's all gone. There's so much water here. I guess I better switch off my desert hat. I don't need it in this environment. Switch it off for a more appropriate hat. And of course, I'll need my rain jacket because it looks a little bit wet out here. All right, explorers, we are going nautical. So let's check out this environment and see where we're at. So it looks like it dropped us off somewhere between 250 and 90 million years ago. I'm not exactly sure where we are right now, though I do know that this is a kind of an accurate representation of what our world would have looked like about 250 million years ago. So there was a large continent called Pangea, where all of our different continents and countries were kind of smushed together into one area. You could see up here where we're at in North America, it's kind of squished into Eurasia, Africa, and South America. So I'm not exactly sure where we are at right now, but I do know that there is a lot of water. So let's see if we can find ourselves an Ichthyosaur. Look, there's one. So the Ichthyosaur comes from the Greek words ichthyos, which means fish, and sauros, which means lizard, translated as fish lizard, which is a pretty accurate statement if you want to look at it because they are actually marine reptiles. They're a group of large extinct marine reptiles. Though the ichthyosaurs belong to the order known as Ichthyosauria, also known as Ichthyotyragea. This was coined by Sir Richard Owen in 1840, though most people just call them ichthyosaurs or Ichthyosauria. But these are a large order, a large group of big marine reptiles. So it's not just one individual, it's a whole bunch of different types of species, and we'll look at the different types later. So we know about Ichthyosaur, at least the namesake. Let's look into or a little bit about their history. So ichthyosaurs thrived during the Mesozoic era. Based off the fossil evidence, this was about 250 years ago until about 90 years ago. So this was into the Jurassic period and up until the late Cretaceous period. Just to give you an idea of where we're at right now, the ichthyosaurs came 20 million years before the dinosaurs. So that's right, we are pre-dinosaur age right now. So let's go look at a little bit of characteristics about the ichthyosaur. So this is a great diagram on the ichthyosaur. It does give that wonderful timeline of the different periods we're in. They first merged 251, roughly, just after the Permian, and then they kind of died off just at the end of the Cretaceous period. This graph also does a great job of listing out the great characteristics that the Ichthyosaur has, but we're going to go into detail about a lot of them soon, so no worries, but it's a great representation. So, how to identify the Ichthyosaur? The first thing you're going to notice is that long jaw. So they have a large skull with a long beak and several sharp teeth. They actually don't really have a neck. It's pretty much all skull and all jaw and all teeth. They also have flippers, so their whole body is kind of modified for the marine environment. These guys were originally terrestrial, land-based reptiles, and then they moved to the ocean and became purely marine individuals. So you'll see a lot of things. They have the flippers, but inside the flippers you can actually still see their phalanges or their finger bones from when they were walking on land. But they have these modified flippers to help them swim. Some of them have dorsal fins, some of them don't. And then they have the tail that helps them whip around. They kind of move through the ocean like this, like an eel, and they were very fast swimmers. No matter what size they were, these things glided in the water. This picture, I have two side-by-side pictures, one of them of the Ichthyosaur, the other of a cephalopod, a giant squid. The reason I have these both together is that these guys are the contenders for having the largest eye size in the entire world. So ichthyosaurs are believed to have the largest ever recorded eye size in the world. They did this by measuring, they have a bone that surrounds their eye, in their eye socket. They've measured that out and they've determined that the eyesight or eyes are huge. In some individuals, over 10 inches in diameter, in length. That is enormous. Think about it. Our eye is about an inch across. That's 10 times bigger than our own eye. It's incredible. The giant squid, pictured at the bottom, was believed to originally have the largest eye recorded, and they are the current living species that have the largest eye in the world. And they like to live in dark, low light, deep waters. They hunt and they use their eyes to reflect what little light there is so that they can hunt in these deep waters. So it is believed that the Ichthyosaur kind of has a similar environments than the squid. So they live in low, deep, low light waters, and they can hunt in these areas with their large eyes. Which brings us to our great segue about eating. This is actually a fossil with some little tiny fish bones inside, so it's really cool that that was able to be captured in the fossil record. So the Ichthyosaur had those razor sharp teeth, long jaws, and those were used to be predators. So a lot of times in the fossil record, it showed that the Ichthyosaur were partial to eating cephalopods and fish. So squid-like creatures and fish, which makes sense because as we showed in the last slide, they have large eyes and that helps them in low light. And what do you find in deep low light water? Other squid. So they love themselves some squid. There are fossil records showing that they sometimes ate large sea turtle eggs or other birds, but most of the time it was cephalopods and fish-like creatures down in the deep depths of the ocean. A new other cool characteristic is actually they gave live birth. So you can think of a marine turtle, like a sea turtle, same thing, a reptile that swims and is mostly marine. They lay eggs on the beach, whereas ichthyosaurs, they actually give live birth. So they have their babies in water. I don't know if you guys can zoom in on this fossil piece, but you can kind of see a baby ichthyosaur coming out from this mama. So it's pretty cool that they have this trait. It was one of the traits that they took on when they were terrestrial reptiles that they brought to the water. So here's an overall complete drawing of a Ichthyosaur skeleton. You can see a lot of the features that I've been talking about. They have their modified paddle flippers that you could see the little phalanges or the finger bones, still remnants from when they were walking. You can see their long tail that they used to whip around in the water. You could see their giant skull, barely any neck, large eye socket, all the characteristics that make a great swimming predator. Now, this is evident through the fossil record. Ichthyosaurs were found everywhere. This is just a small map that I could find of about 250 years ago about places where you would have found an ichthyosaur. So in this graph, or in this picture, they found some over in Australia, up into North America, and over into Kazakhstan, Europe area. And you can find these ichthyosaur skeletons in so many places, all over Europe. First ones I think were found in Asia and even here in North America. So these guys were pretty prevalent around the entire world. And when the world is your ocean, you know, they'll take advantage of it. This is another cool diagram I wanted to show you guys. This gives a better description or a better picture about those modified paddles. You can see those fin bones and remnants of a hand turned into a flipper. And then at the bottom is an evolutionary chart. So there were two branches of current reptiles. We have the snakes and the lizards, and then the other branch, which is the crocodiles, the dinosaurs, and the birds. It is believed through the fossil record that ichthyosaurs broke off before those two split, and so they're kind of their own sort of branch in the evolutionary line. So they don't seem to be really related or connected to these other two branches from reptiles. So these diagrams give a really good idea of what a land reptile turned into a marine reptile would look like. They currently have an unknown reptile descendant that was on land, but you can kind of see what they might have looked like. You can see at the top we have a walking reptile, small skull, fingers and legs to walk, small skinny tail. And as you go down in the pictures, you can see some things start to modify. The tail gets longer, the skull gets bigger, and the legs start to be pushed back, and then at the point of when they've become completely marine, they are turned into paddles. So no longer fingers and things that you can walk on. So by the end of it, they have a large skull, a long tail that they can whip through the water, and pretty much flippers and no more legs. So this is a good idea, and you can see the fossils on the bottom that represent our different ichthyosaurs. And it's interesting because we actually have a living species that represents that very well. The dolphin. So the dolphins, like the ichthyosaurs, had ancestors that were based on land. Actually, dolphins had hoofed ancestors. So their ancestors lived on land, had hooves, and eventually made their way into water and found that marine life was a better suit for them. So they modified their body, and through the evolutionary timeline became more and more suited for marine life. And it's cool to see, if you compare the two, the ichthyosaur and the dolphin, they shared a lot of similar traits. And just to go through a lot of these, they had nostril openings, so neither of these have gills. They still breathe air. Eyes modified for low light hunting. They both gave live birth. They both have, babies. Their skin was modified for swimming, nice and smooth. The skull, large skulls with an prolonged rostrum or a long beak. All these different things that show the similarities between ichthyosaurs and dolphins, which lets me tell you about a scientific term called convergent evolution. So it's best described by looking at these three different pictures. We have the shark, which is a shark, Ichthyosaur, which is a reptile, and a dolphin, which is a mammal. They all look very similar or have similar builds. They have the smooth body, the dorsal fin, the no neck, and flippers. But these traits are not passed down because these guys are related. These guys are actually not directly related to each other or even close. But they all look similar or have similar traits. So these features weren't passed down through ancestors, but they came up because they live in similar environments. It turns out that if you're smooth and you have a dorsal fin and flippers instead of legs, you do really well in these environments. So those adaptations were pushed when these creatures were in these environments, and so they all looked very similar. So in a way, convergent evolution means traits that are evolved because they live in similar conditions, but not because they're related. So it's pretty cool to see, especially since we have living representations of this between the sharks and the dolphins today. And it's cool to see it compared to the Ichthyosaur. Now, all the research on the Ichthyosaur can be accounted for one woman in history, and her name is Mary Awning. So before the 19th century, there was Ichthyosaur bones. It wasn't a new feature. It didn't just come up suddenly. Most people believed they were crocodiles, and so there wasn't much thought put into the Ichthyosaur bones that were found. But that all changed when Mary Awning came around. She was born between 1799 and 1847. She lived on Lyme Regis. It's a place down in the south coast of England. And Lyme Regis became the birthplace of the ichthyosaurs because of the work that Mary did. So her and her brother Joseph were able to find a complete specimen. They actually found a full skull and almost put together skeleton that sparked the revolutionary finding of ichthyosaur information and bones and skeletons and fossil records. Mary Awning was the first person to illustrate the accurate ichthyosaur skeleton make. All of her collections and findings were later put into museums and sparked a popularity of ichthyosaurs in the scientific community. So throughout the 19th century, every museum wanted their own ichthyosaur presented. That was a cool thing to have. And it all started with Mary Awning as the first person to find interest in the ichthyosaur. She's regarded as the first paleontologist female. So you go, girl. Thank you so much for allowing us to know more about the ichthyosaur. This is actually the original skull that was collected from her back in 1811. You could see the accurate details that you could observe in the skull. You can even see the sclerotic ring, the eye bone in the skull. You could see even rows of teeth in the skull. It's incredible what they were able to capture in the fossil record and what she was able to find way back then. This is currently on display in the Natural History Museum in London, in UK, and it's approximately 120 centimeters long. Here's another fossil, complete ichthyosaur skeleton that's displayed. You could just look how well preserved these are. No matter millions and millions of years that have passed, these guys still look pretty amazing. You can even see the phalanges or the finger bones presented in this skeleton. It's a very cool fossil. This one, oh my goodness. So this fossil you can actually find at the Royal Tyrrell Museum. So this ichthyosaur belongs to the family Ichthyosauridae, pardon my Latin. And this one was collected in British Columbia, Canada, and it was described in 2004. They believed this giant lived about 215 million years ago, and it has a maximum estimated length of about 21 meters, which is about 68 feet. That is about the size or bigger of a blue whale. These guys got ginormous. This study actually re-examined several giant bones that were collected over 150 million years ago. 150 years ago from a fossil site in the UK known as Cliff. And here they found a lot of bones that were disarticulate or broken or not fully complete. And therefore, at the time, they couldn't really give accurate descriptions on it. But based on observations on the jaw size or kind of what fragments they can find, they found particular individuals could be over 30 meters or more in length. That's 90 feet. My goodness, these guys were big. And they are the contender for being the largest animal that ever lived. So hopefully we can always continue more of this research and find more about the ichthyosaurs. So I mentioned to you before that Ichthyosaurs was an order, a general term for a lot of these different types of marine reptiles. Here's a great accurate representations of the different types of ichthyosaurs that were around. Most of them were about 2 feet to 4 feet in length, not very big. But as you saw from that fossil way back then, they can get huge. The Shoniosaurus can be ginormous. Here's a better size representation of this big giant. You can see a human here, and we have our two species of the Shoniosaurus, which is the Shastosaurensis skinninensis and the Shoniosaurus populus. Pardon my Latin, I am very bad at speaking Latin. But the cool thing about the Shoniosaurus is that, let's go back to Nevada State Fossil. The fossils of the Shoniosaurus were first found in a large deposit in Nevada in 1920. 30 years later, they were excavated and uncovering the remains of 37 very large ichthyosaurs. And they were named Shoniosaurus, which means lizard from the Shoshone Mountains. That's right here in Nevada in our Shoshone Mountains, in the habitat of our Shoshone Native American tribe, these guys were found. So the Shoshonesaurus populus, or S. popularis, was adopted as our state fossil in 1984. Excavations on these fossils actually began in 1954 under the directions of Charles Camp and Samuel Wells through the University of California, Berkeley, and they continued to do research between the 1960s and 70s. All of the a lot of their findings and fossil site can be currently viewed at the Berlin Ichthyosaur State Park. This is found in Austin, Nevada. Huge collection of ichthyosaur remnants. So the Berlin Ichthyosaur State Park was first established in 1957 to protect and display North America's most abundant concentration of the largest known ichthyosaur fossils. The Berlin part of Berlin Ichthyosaur State Park is about preserving a turn of the 20th century mining town in Berlin and the Diana mine. So it's also, not only is it a fossil museum, it is a museum for a historic mine in Nevada. So I definitely recommend making your way to Austin, Nevada one day just to see these giants in action, in fossil record. Be your archaeologists, explorers, and go check it out. I will say that due to COVID-19, there are closures. I think it's currently closed due to COVID-19. So just make sure to check out on the Berlin Ichthyosaur State Park website before you decide to make a trip out there. Make sure that it's open and you get to see these marine giants. Now, the ichthyosaurs were very prevalent during this chunk between 250 and 90 million years ago. They were very successful, very much prevalent and flourished throughout the Triassic, Jurassic, and early Cretaceous geological periods. And that's evident from how many different ichthyosaurs have been found all over the world. However, mysteriously, during the late Cretaceous period, at about 90 million years ago, all remnants of the fossil record for ichthyosaurs suddenly disappeared. They just magically stopped appearing, stopped being there. No more ichthyosaurs. Now, you might be saying, Explorer Torie, what about the asteroid that killed the dinosaurs? That's a pretty good theory, except for the asteroid that killed the dinosaurs came at about 65 million years ago, whereas the ichthyosaurs disappeared 90 million years ago, so 35 million years before the dinosaurs went extinct. So what happened? Where did they go? So what they believe, because there's different theories out there, nothing hasn't been proven absolutely, but there's debates on if predation. There were other big reptiles, big creatures in the water, and they could have had predation issues, competition that would have lowered their numbers. But because they disappeared all at the same time very quickly, the leading contender for what happened was actually climate change. Yes, they believe that the climate changed in a way where the ichthyosaurs no longer could thrive, they no longer could adapt, and they no longer could live. So it's an important lesson to learn about our future in terms of climate change, that when things change too rapidly, too much to where you no longer can adapt to the situation, it may call for your extinction. So just be mindful of climate change. If there's any way you want to help with your carbon footprint or helping out with climate change, please let me know. I can definitely give you some tips and some resources. But it's interesting to see climate change in action by looking at the ichthyosaur's past. So that's pretty cool. But that's all I have on the ichthyosaur. I hope you guys liked going back in time and checking this out. It was pretty cool. The ichthyosaurs are a great giant that has a great history on Nevada. So I'm going to open it up to questions. If you have any questions about this presentation or biology in general, just go ahead and type them in the chat and I'll answer them for you. Looks like we have a couple of questions coming in. How do we know that sharks, dolphins, and ichthyosaurs are not related? That's a really good question. The easiest way is to look at the characteristics that they share with their other animals, with their related species. So for instance, dolphins are mammals. Their fossil records clearly show the characteristics of them being mammals, whereas they had hair, live birth, they produce milk, all the characteristics of a mammal. Whereas the ichthyosaur has all the characteristics that were presented in a reptile. They have, the long bodies, long tails. They have the skull shape, very similar. The live birth is actually something that other reptiles had as well. So that was also a characteristic. And then sharks, of course, they are known as cartilaginous fish. So they are made up of cartilage instead of bones, really. And they are pure fish. They have gills. They don't breathe air. So they are more closely related to fish than ichthyosaurs and dolphins. And dolphins are more closely related to mammals. And ichthyosaurs are more closely related to reptiles. And this is all observed through the fossil record, and is all observed with dolphins and sharks. Just looking at their characteristics of how they live, how they survive, how they move, and what shared characteristics they share with other living species. So to answer your question, I guess in a small little section is that they use evolutionary history and scientific research to find out when these different animal species came about in the evolutionary timeline, and the point where sharks, dolphins, and ichthyosaurs would have come together would have been way, way far along. They wouldn't have really had a common ancestor really until many, many years ago. So they're not closely related, and therefore their traits would have not come up through being ancestors in that way. Why did dolphins and sharks survive but the ichthyosaur didn't? That's actually a pretty good question, and that is what scientists are currently deciding right now. And there are different things like the a lot of the different large sharks, like the Megalosaur and different larger predators like that, disappeared during that period as well. So it wasn't just the Ichthyosaur, though I didn't really examine the Ichthyosaur compared to other creatures, but there are a lot of mass extinctions during that time. The sharks, I think, are a smaller version of what the bigger sharks would have been, so maybe that could have been a trait, though there were other ichthyosaurs that were much smaller. So it's honestly a big mystery. I honestly don't know, because the climate event that happened, you would think would also impact sharks and dolphins being in the same environment too. So that's the great thing about scientists, or being a scientist, is that you can run tests and run theories and see what works and see what doesn't work. But I'm sure with the amount of ichthyosaurs that are available in the fossil record and the current studies that they're still doing on them, maybe we'll get an answer in the future. But I'm not exactly sure what temperature change or tidal wave movement, something that could have ended the ichthyosaurs but kept our other marine animals still alive. But looks like I don't have any further questions. If I missed your question, or you have one and this presentation has ended already, go ahead and just type them down and I'll answer them after this presentation. So thank you so much for watching. I will also be featured on this Saturday's Conservation Storytime. So each week on the Nevada Conservation League, we have a live speaker do a children's book for the community. Usually it involves the environment or scientific community, or along the lines of that. One of the books, the very first book I'm going to be reading, is called A Girl Called Mary. She is Mary Awning, yes, the woman who helped spark the Ichthyosaur in paleontology. So I'm going to be sharing a small kid's story about Mary. This will be on Facebook Live this Saturday at noon. So please check it out if you want to learn a little bit more about Mary. She had an interesting past. Spoiler alert, she actually got struck by lightning. That's weird. But yeah, I hope you enjoy that story and check it out this Saturday. But our next native Nevada creature, I'm going to give you guys a riddle. And with this riddle, hopefully you can figure out which plant species will be featured on the next spotlight. All right, this is the riddle. I'm a large plant native to the Southwest. In the Mojave Desert is where I do best. By sight, I'm a cactus. By name, I'm a tree. But I'm actually a yucca, as tall as can be. A biblical man and I share the same name. I'm also called the Spanish dagger, with spikes to blame. There's the riddle. So good luck figuring that out. If you have an idea, go ahead and post it on our Nevada Conservation League Facebook event page for Native Nevada Nature. And if you're the first person right, I'll give you a special shout out on next week's presentation. So good luck, put your thinking cap, explorers, and let me know your thoughts. But until then, thank you so much for checking out Native Nevada Nature. Each week we do a spotlight on a native plant or animal species, and I really enjoy teaching you guys about our community, our native communities. So thank you for being with me each week. If you like this presentation, go ahead and hit the like button or give us a heart or add your comments and your thoughts. We like to do these presentations often. We want to know about the engagement or if people are liking it. So if you like it, give me a like and let me know that you are enjoying this so we can continue to do this once a week. But until next week, keep on exploring.